a great pleasure to be together to launch this event. I know we're expecting a number of additional participants, and I'd ask Young to close the door but leave it ajar because I think it's locked, and we're going to have to bear with this through the boot camp. So my name is Nathaniel Osgood. I am honored for the opportunity to be with you today and for the balance of the week to share with you a really unique combination of materials. Combination of materials that I believe lay the groundwork for a very exciting new confluence of scientific disciplines, which I like to label systems data science, and where those disciplines draw on the best and most insightful components of system science on the one hand, the science of the whole, with the insights that are rapidly developing within the data science area, the science of drawing insight into the world through empirically rich sources of data, and particularly sources of data that are subject to the 4 V's. They're big, lots of data, high velocity, high variety, and high veracity. Within the course of this week, I am going to take you on a tour through some of the most promising and significant practical linkages between these two rapidly developing areas of science, with a specific focus on how they apply to yield insight within the health area. This is the second time that this boot camp has been offered. The first time this past November. But really, this is the first time that participants will have the opportunity for a more fulsome exposition from the standpoint of a coherent systematic perspective on system data science, to be able to understand this material. And the materials that you'll be seeing today have benefited from further refinement and indeed further extension since the first time this was offered. We're very fortunate to have with us throughout the week a variety of case studies and a variety of guest lectures on particular aspects of this, particularly from the students here. I welcome the new participants. I request that the door be left ajar because we're expecting a few more people yet, but appreciate their bearing with it. So within the course of this week, we're going to be having a unique opportunity to examine methods that not only straddle system and data science on the one hand, but really bring each of those methods to their full potential and that synergize them. Not only will these different rapidly developing areas of science be shown to be compatible, but in fact synergistic. And throughout the week, we'll learn more about the particulars of these synergies and see many examples of them. So I'd like to begin, though, the boot camp with just some administrivia, some basic orientation, and drawing your attention to some resources that will stay with us throughout the event. So the goals of this boot camp are as follows. It's really to provide a high-level appreciation for why it's important system and data science be applied together, and as to the unique advantages and synergies that come from applying these together. I'm going to be providing guidance as to the ways particular techniques can play a role in uniting these disciplines, and provide some high-level understanding of the operation of these techniques, recognizing that the most detailed discussion of these techniques will need to turn to additional materials beyond that covered here. I'm going to be, and I already have in fact, provided resources to ease application of these techniques by researchers, and we'll try to interweave in the course of the week theory and practice as to these combinations, providing you with concrete examples in the form of models, in the form of code, that bring together this data and system science. And finally, I'll be introducing some sources of big data, which will both help motivate why these techniques provide such a rich synergy, but also serve as practical exemplars of the value of big data within the health sphere. Okay? So today in particular, we'll be laying a lot of these basics, these foundations, talking to make sure people are on board with an understanding of system science at a very basic level and a glimpse of three major traditions. An introduction to system science at a high level and its relationship to a cluster of terms: big data, machine learning, artificial intelligence, etc. Talking about the ways in which they come together in system data science perspective, and that perspective and the set of principles that accompany it. And then turning to a set of big data sources within the health sphere, and in a final case study, seeing one way in which they can be used to inform understanding within the health sphere. I don't have the time or opportunity to offer here a comprehensive survey of data science or system science. That would be the subject of several semester-long courses, and realistically, we can't accomplish that in the week. But we can give a glimpse of a lot of the most salient components of each when it comes to the shared enterprise of system data science. I'm not going to be able to provide the most detailed tutorials on any one method, but I can refer you to resources where I have done things like that, and I can further offer for participants to speak with the many TAs here to secure those tutorials on a one-on-one basis. And finally, I can't promise that everyone will leave this room like Athena full-born from Zeus's head, with a full and detailed facility in applying system and data science tools. Once again, there's a lot to be learned from the students here. And they can show you particulars of using various tools to pursue system and data science techniques at a practical level. And you can further draw on the many scripts and the models that we've provided, but I can't provide a guarantee that you will become a virtuoso on those within the course of the week. Okay, I will aspire, both for those participants who are here and those who are attending this boot camp remotely because of visa challenges, and I know there's several of those. I'm committed to making screencast recordings of the boot camp, and you can find those screencast recordings as they accumulate through the boot camp within hours of delivering each lecture. They should be posted on this YouTube playlist, okay? And I will do my best to make sure that the audio quality is sufficient, and that I try to repeat questions so that questions from the audience can be heard and appreciated on those recordings. And to that end, please do remind me if I forget to repeat questions. Likewise, beyond the course videos I've just mentioned, there's a set of course materials, okay? Already, these materials have a lot posted there, and there's going to be a lot more coming in coming hours and days as I post additional lecture slides, as examples are posted, as guest lectures provide their lectures and slides, etc. So this is a set of materials. These materials are broad in their composition. They include slides, They include models and code bases. They further include a set of background materials that provide references to the literature that might be of interest, as well as some discussion of additional resources. I further, in those materials, have provided a set of briefings on certain types of needs that come up in this boot camp, and a sort of perspective on systems data science that's about a page long, but will give you the crux of the philosophy and perspective I'll be taking in this boot camp. I'd invite you to go make use of those resources, because I think if you were to look over them later today, or over the course of the next few days, you'll draw additional understanding of a lot of the material that I'm talking about. Okay? Case studies I'll attempt to post those there as well, even though those will go largely unrecorded. We will post the slides, okay? So please make use of those materials early and make use of them often, because it's going to be a repository of some note. Okay, teaching assistants within this boot camp play a key role. Many will be providing case studies, and I appreciate very much those teaching assistants who have volunteered to do so. I also want all these TAs to serve as resources for the participants in terms of addressing your particular needs and questions. Please bring those questions forward to me, but if you would rather pursue them in an interactive way, sitting side by side with a student, maybe prototyping out a model or having them look at a detail of some modeling plan that that you have in mind, please pull TAs aside. It's a good part of their education, and chances are they can bring a lot of insight to your needs, or refer to another person who can take it even further. The materials I provided, such as example models and code bases, should all be within the range of the TAs in this room. Not necessarily on an individual basis, because TAs have different levels of expertise and different techniques, but collectively. So if you want to know about the PMCMC code base, for example, Xiaoyan is a great person to talk to. Particle filtering models, a set of people here have worked with them. If you want to examine the scripts for working with Ethica data, there's another set yet. So I suggest that you tap the TA expertise if you want to dive into some of these models and tease out how they work, what they're doing, how they need to be adapted to your needs. And really, if you'd like to apply these techniques in your area, please work with the TAs over the course of the week, and where needed, me. I'd be glad to kick in suggestions as well to try to advance your ideas. This is a lot of the purpose of the boot camp, is to provide those present with the opportunity to do so. Okay, a couple practical essentials. This is the first time we've delivered this boot camp in the room. It reflects the fact that our standard rooms during the summer semesters are highly subscribed, and we have made use of this room because it seemed to be a good fallback when those computer labs are not available. This is the first time we've used it, and we're learning. We're learning about the heat situation, the noise situation. Please provide feedback to us. Christine has kindly offered to work with facility management on the heat situation, and we can probably similarly interact with the library staff. One practical consideration for this room is that the door is, as I understand it, locked by default. Okay? If a TA or participant is outside and can't get in, please knock. And the TAs in the last table there, such as Young, Chen, and Rifat, or Bryce and Alex, please go around and let them in as soon as possible, okay? But don't hesitate to let us know that you're outside. It's an awkward situation, and I don't think that's something we're going to be able to change in the course of the week. Okay, if you go out the door, washrooms are there'll be a big desk to your left, which is a library checkout desk. If you bear left around, or bear to its right, sort of just move around it, the washrooms are back there in that corner. And I think there's a water fountain out there as well. If you need to make a phone call, because this is a library, it'll be hard to do right here. But if you go out and you go back through the anti-theft devices, metal detectors or what have you, you'll find a foyer where you should be able to talk easily as well. I mentioned the Google Drive site. There are preliminary presentations. There will be adding more. And there are Wi-Fi networks involved. For the participants who are here, if you haven't gotten on the Wi-Fi network, my understanding is that all of you in your name tags should have listed a login name and a password, which I believe is on the longer side, to type in. You should connect to U of S Secure. That's the network.
Guest.
It's guest.
It's guest.
Oh, I'll be. U of S guest. Okay. Oh well. Learn something every day.
Yeah,
so
I
they
made the
decide to
same
use
mistake
guest
earlier
this time,
today,
right?
but it's guest.
Okay.
And then when you attempt to load a website,
I stand
show
corrected.
a login
Yeah.
in the browser.
Okay. And and that's even for the usernames and passwords provided.
Yes.
Amazing. Okay. Remarkable. I'd love to talk more about that, but we'll save that till later. Okay. So those are some practical essentials. Thank you for bearing with this. Let us know of problems, and we'll do what we can to address these needs. One thing that I'm a little bit worried about is the noise from the fan. And I'd like a TA, maybe Lavi or Olivia, to check the audio at the end of this session to make sure, to assess its quality and let me know about any problems, fan or otherwise, okay? It's always nice to have fans, but this one may pose some problems. Okay. So, just a couple remarks about overarching themes that we'll be returning to again and again in the course of this week. This week lays out a vision of system data science that's more than a clumping together, an aggregation of the two. That lays out a notion of system data science where the whole is greater than the sum of the parts. Within that, that notion, there are elements woven together from different sides. A key element is dynamic complexity. Complexity of systems that is not merely a kind of a informal acronym for complicated, but it's complex in the sense that a system cannot be reduced to merely a sum or an average of its constituent parts. And at a technical level, the systems we're dealing with are typically nonlinear. Okay? This has many specific implications and illustrations. One of them is that an intervention, you consider two interventions, A and B, undertaken with respect to the system. If we considered each in isolation and were to total up the changes wrought by each of those interventions in isolation, if we put them together, we undertake them jointly, we might see an impact that's very, very different than merely the sum of the impacts of intervention together. Sometimes it might be multiplicative. Sometimes they might work at cross purposes and nearly cancel each other out. That's one aspect of nonlinearity. And it turns out there are many others, which I'd be glad to go into if there are questions. But in generally, the dynamics of these systems, how they change depends a lot on their history, their current situation in the system shapes in a big way how it evolves. And really much of this bootcamp is about bringing that together with data science mechanisms that help us, using empirical data about the systems, understand how that system behaves, both historically, looking backward, and looking forward in the event of counterfactuals. Okay? We're going to see that much of the needs for bringing in system science to data science relate to the ability to reason robustly about counterfactuals, about what-if questions which haven't been observed, and therefore there's not data immediately available to study them, but where we want to reason robustly what would happen if X occurred, leveraging what we can of past knowledge, but recognizing that we're in a situation where the empirical regularities we've observed historically are going to be different because the data generating process has changed. We're going to be talking about a meshing together of data science and theory in the form of dynamic models, models that capture a working hypothesis about sort of the processes operating out there in the world that underlie the data we observe, that weaves together these. Often data science is talked about in a most prominent way in terms of machine learning with models that are more black box-ish. Deep learning models, for example. And those models have a place capturing empirical regularities that lack a really well-known, well-understood theoretic foundation. But we're also going to see how data science can explicate theory, can better help us understand the implications of theory, can inform theory and build theory, can sharpen our theorizing and help motivate theorizing based on the patterns that we observe. And there's this very interesting duality of how data science, while it's about empirical observations, can sharpen our theorizing about the world, these hypotheses we capture within models. We're going to be talking about the use of machine learning techniques, which are sometimes treated as curve-fitting techniques on observables, in a way that allows us to reason about situations where we don't have a curve because we don't have data to fit directly about the counterfactual situation that we're anticipating or we're contemplating, the intervention we're anticipating undertaking, for example. And we're going to be talking about the complementary roles of big data, machine learning, artificial intelligence, and system science as they weave together to form a counterfactual, capable data science, a form of system science where our models are grounded in empirical observations in a rich way, where those observations exist, but can allow us to reason as best we can with the going theory captured by those models as to what might happen in the event of counterfactuals. And where, from a data science perspective, we recognize that the observables that we encounter, the empirical data that we observe, are not merely one-offs. They're not merely solitudes to each other, clusters of observations, each taken in isolation. They are different faces of, different facets of, different sides of an underlying system that gives rise to them. So rather than taking each data set with one or a collection of features of observables in isolation and analyzing it on its own terms, we'll learn to recognize that they are all related to one another. They're cousins of one another by coming from an underlying system that gives rise to each of them. And this is a profound thing, it's suggested by Taken's embedding theorem, any one data set will often whisper to us about the broader system that gives rise to it. And so we can better understand that system as a broader construct through one data set, another data set, and another data set. And by combining them, give a picture of the broader system, even those areas of the broader system that we didn't measure directly, but which are collectively implied by what we do observe. And we're going to see how we can do that with models. And as time allows, with techniques such as embedding and its logical consequent of CCM, we'll see how we can gain insight into the causality underlying a system using the evidence from different data sets within the system. So these are some themes that we're going to be seeing writ large through the bootcamp, and we will return to those themes again and again to drive them further home, and with respect to particular examples. Okay. So those were my remarks about the broad features of the bootcamp and Administrivia. Any questions at a practical level that I can answer? Recognize that I'm now going to be diving into a lot of particulars to substantiate what I'm talking about on this slide. Any questions I could answer? Pointers? Okay. I guess I should have mentioned one thing about food. We clearly have here at the back of the room a set of refreshments and breakfast items that will be present every day. We will further have delivered to us later in the morning and then subsequently mid-afternoon a set of other items as well. Okay, so there should be food provided here through the day. These include coffee and tea. If anyone is looking for additional refreshments or snacks, I would note Starbucks is just out the way and to the side there. There are also rooms out there if you want to take a student aside and have a deep discussion about one of the example models or code bases. There are rooms the students can reserve, and they're small breakout rooms, and you can engage with students more easily there than in the corner of this room. For lunch, each of the participants should have in your little lanyard badge, should have a meal ticket, okay? These are meal tickets, I believe, which are daily meal tickets. I believe each of them is for a particular day. We will be going to a place called Marcus Hall, which is very close geographically to this, but I'll ask the TAs to guide you. We can go there inside or, as you see fit, outside as well. So it's a buffet lunch. It does offer a wide variety of options, vegetarian, gluten-free, and there's enough variety that those with any concerns about allergies, etc., should be okay. But we'll try to make sure that we have some time to talk as a group there over lunch each day, and then we'll reconvene here after about an hour's lunch. But it is a buffet setting where you should be able to take food to your liking. Okay? Okay, so those were some initial comments. If there's no questions, I will go on to jump into the first set of material then. Okay. Another point I should have added to the slides. I have provided you a provisional schedule for the week. That's in that set of materials that I linked to just a few minutes ago. I would suggest, nay, I would recommend that you go here, and if there's one thing you get from here today, these materials, it would be this provisional schedule. Not because of the details of the timing, although it might be useful if you're planning a phone call or anything, but because for each lecture, each of the main lectures, I have provided a set of summarized lessons, of takeaways from that lecture, okay? And I spent a fair bit of time to try to take care to communicate the gist of what I'm trying to carry across in these lectures and summarize it beneath each. And if you refer to that, you'll be further ahead in understanding some of the major themes and points I'm trying to convey. So I'd suggest that you refer to that, and it wouldn't hurt as I'm calling up the slides to preview it, because it will give you a good orientation for some of the key takeaways that I want to hammer on. Okay, so please refer to those lessons for each lecture, because they collectively do convey, not only do they sharpen an appreciation of a particular lecture, they collectively convey some of the main ideas of this boot camp. Okay. Now, when I provided the pre-survey to the participants, I asked some questions about backgrounds for people, and I found that most of the people here had some exposure to simulation modeling when it comes to exploring issues, particularly in the health sphere. I therefore am not going to spend as much time talking about the basics of this as I might otherwise, but I did want to hit on a couple features of this and talk a little bit about its three major traditions, because we will see multiple types of modeling in the course of the week, and some people may be familiar with one type but not others. Okay, and I want to hit on a little bit of exposition of each to give you a point of orientation for understanding the models, including those I provided to you on